kids, Mrs. Geiger here. In this video, we're going to talk about balancing chemical reactions. All right, so we've talked about chemical reactions and the types of reactions that exist, but today we're going to talk about how we balance. All right, so balancing is this idea that you can multiply any substance by a whole number in order to show that you have multiples of that. So I'll show you what I mean in a minute. But first we're going to talk about the law of conservation of mass. So think to yourself, what is the law of conservation of mass? Right now that you have an idea of what the answer is, let's see if you are right. I'm going to put this in the magic answer box. Let's see. That's good. So, if you said that the law of conservation of mass says that nothing can be created or destroyed, remember we wrote down a more complicated version of this, but that means that when a chemical reaction occurs, no particles can be lost. So the mass of the reactants, or the total number of particles has to equal the total number of product particles. All right, and just a little review of chemical reactions. We're going to have our reactants on the left side of the reaction. So let's say, just as an example, we can have A plus B. These are not real chemicals. I'm not trying to represent boron there. Yields AB. These are variables. And we remember that this arrow is used to say that a change has occurred. What do we call that arrow? We don't read A plus B arrow AB. You got it. We read yield. Or yield. So that's the yield symbol. So no equal signs in a chemical reaction. And we're going to use this arrow and we're going to call it a yield sign. All right. So A plus B yields AB. So that would be an example of a synthesis reaction. All right. So let's take a look at our first example of a synthesis reaction here. It just happens to be, I just happened to pick this reaction because it's so super common. All right. So let's take a look at this. So we have H2 plus O2 yields H2O. All right, so this is the synthesis of making water. But we have an issue here because this is not balanced. It is breaking the law. Oh no. So I have the particle diagrams down below. So I'm going to represent my H2 and my O2 like this. And then my H2O is there on the right. And you'll notice that I am representing it bent. So, which element is out of balance? Which element do the amount on the left side not equal the amount on the right side? That's right, it's oxygen. So you'll notice that you have two oxygen atoms on the left side of the reaction. But we only have one oxygen atom on the right side. That can't happen. So we need to multiply our H2O to show that for every time water is made, there's going to be two oxygens. So that means that I'm going to end up making... Let me just make another water molecule. All right, and there is our other water molecule. So it's going to have to make two water molecules. So how do we write this in the chemical reaction? We are going to use a 2 coefficient to show that there are two molecules of water. So a 2 subscript shows you that there's two hydrogens, and that tells you how the water is chemically combined or bonded. But the 2 coefficient shows you how those elements are physically combined. So now something else is out of balance. What other substance is now out of balance because there's a different number of particles on the left side than on the right side. You got it, you got it. It's hydrogen, right? So now we have 4 hydrogen atoms on the right side. So we have to go back and fix that and make there be 4 hydrogen atoms on the left side. So how could you do that? What could you multiply by? All right, you got it. You could multiply by 2. All right, so there'll be, it will say 2H2 plus O2 yields 2H2O. And now we're balanced because we have 4 atoms of hydrogen on the left side and 4 atoms of hydrogen on the right side. And we also have 2 atoms of oxygen and 2 atoms of oxygen. Now remember, the subscripts are determined by the valence electrons. So that's set already. So you can't change the subscripts once you figure them out. H2O is H2O because oxygen has 6 valence electrons and hydrogen has 1. And that's how they're going to react, where we're going to have sharing of those electrons. All right, so the 2 here can't get changed, but this 2 coefficient shows you that you're going to need 2 of them. All right, let's move on. All right, so you'll see this very often where when we're balancing equations, we write a line out in front of those symbols to show that we're going to be balancing it. This is only ever done when there's questions about balancing being asked to students. So the Regents does this, and they'll put these blanks out front. And it's just to show you that there's room for you to write the number there. But normally we don't write those. All right, so let's draw a particle diagram for iron. So iron would just be 1. And oxygen, let's make that red this time, and I'll leave those circles open, make my life a little bit easier, to be O2. So right now we have 1 iron on the left side, and on the right side I have this iron 3 oxide. I know it's iron 3 because iron needs to have a +3 charge in order to balance out the 3 oxygens minus 2 charges. So I just use my little trick of crisscross there to show me that we're going to have 3 oxygens and we're going to have 2 irons. Now, you need to think back to when you learned about lowest common multiple. All right, so I have 2 oxygens on the left side, and I have 3 atoms of oxygen on the right side. So what would be the lowest common multiple? What number how could I multiply these so that I get the same number of oxygen atoms on the left side as on the right side? What would the number of oxygen atoms total be on the left side and the right side? Wonderful, you got it. You need 6 atoms of oxygen on the left side, and you're going to need 6 atoms of oxygen on the right side. So I'm going to go ahead and multiply my O2 by 3. And that will give me 1, 2, 3, 4, 5, 6 atoms of oxygen. Now I'm going to need 6 atoms of oxygen on the right side. So I'm going to multiply this, since I have 3, by 2. And I'm going to make another iron 3 oxide. 1, 2, 3, and then I'm going to, I can't change the way that this is bonded, draw my irons in. So what you'll notice here is that when I put this 2 out front, it's going to distribute to each of these. So I'm going to end up with altogether 6 oxygens, because 2 times 3 is 6, but I'm going to end up with 4 irons, because 2 times 2 is 4. So now, which element is now out of balance? That's right, it's iron. So now I'm going to need to multiply iron so that I can make sure that I have the same number of iron atoms on the left side of the reaction as on the right side. So what coefficient should I put in front of iron on the left side? That's right, we're going to need to have 4 of these. So 1, 2, 3, 4 of these. Iron atoms. Now we have 4 iron atoms on the left side, 4 atoms on the iron atoms on the right side, 6 oxygen atoms on the left side, and 6 oxygen atoms on the right side. So the balanced chemical reaction here is 4 Fe plus 3 O2 yields 2 Fe2O3. All right, that's how I would read that equation out. Now, why did I start with oxygen? Well, how did I know that I was going to do oxygen first? And the answer is that if you have something that's an element, but it's not diatomic, like iron, there's just one of them. I can multiply that by any number, and it will work out. But iron, iron I can do last, because whatever the number of irons I end up with on the right side, I know I can multiply on the left side. I started with oxygen because I have 2 oxygens on the left side, but I have 3 oxygen atoms on the right side. So that was the one that started out the most unbalanced, and I did that one first. You can start out with iron, but you'd end up multiplying by 2, and then you'd realize you needed to multiply by 2 again in order to get up to 4 atoms. So the reason this is called balancing is because you multiply something on the left side, it changes what's on the right side, you go back and fix it, and you go back and forth until you end up with the same number of atoms on the left side of the reaction as the right side of the reaction. All right, that's it for this one. Thank you.